Are you building a web app with multiple teams, and is there a great divide between the front-end and the back-end developers? Are you not comfortable adding UI-specific code and logic to a very generic back-end API or back-end service? Do you need to call multiple microservices in gRPC directly from your React codebase in the browser? And is that turning out to be a hassle or a bad idea? The backend-for-frontend pattern might be a solution. Let's take a look at what it is and when you would use it. So what is the backend-for-frontend pattern, also called the BFF? Conceptually, any client-facing application, any user-facing application consists of two components. One is the client-side codebase itself. This could be the native app that you install via the App Store, or it could be the single-page application code that is running in the browser, the HTML, CSS, JavaScript. That's the first component. The second component is some sort of server component. This could be a separate service that is specifically tied to serving HTML and stuff like that. It could also be a plugin in an API gateway that your cloud provider has, for example. If you look at the larger scope of your application, then there's probably a backend with the database and maybe multiple microservices or one monolith, it doesn't matter. And the BFF here is the layer in between this backend and the client-side application. The thing is that any user-facing application has both a client-side and a server-side component, because something needs to serve the HTML. Something needs to serve the API to a native app. And there's a lot more to simply serving HTML or simply providing an API. There's actually a whole class of things that need to happen on the server that are UI-specific. And that's the reason the BFF exists. So in essence, the backend for frontend is some code server-side that implements the front-end logic that needs to be server-side, because not everything can be client-side, realistically. And this can be as simple as rendering the HTML. When you have a server-side rendered HTML, the backend for frontend is the place where you do this. It could also be an API, if you want a GraphQL API, but the backend landscape, the monolith you have to deal with or whatever is REST or gRPC. Now you can choose to use GraphQL here, if that makes sense for your client code. So your React or your whatever framework you're using can now use GraphQL. The idea here is that your client-side code, whether that's a native app or the JavaScript running in a browser, is only calling one backend, one API, and that's the thing that's implemented by the backend for the frontend. So otherwise you're not using the backend for frontend pattern correctly. And specifically when building a web app, there's many HTTP features that require a server-side implementation of some sort. If you need to redirect to a specific authentication server with specific headers, if you need to offer downloads, that also requires an HTTP header, if you need to set security headers for CORS or cross-site scripting or whatever, if you need to offer error pages like 404 or 500. And of course the most obvious one is just serving HTML and serving the statics, so CSS and JS, which are compiled and bundled together. Yes, there's other solutions to do that, but the backend for frontend is now a single concern. It's a separated concern that is just dealing with all this front-end specific stuff that just happens to be server-side because of the limits of technology like HTTP. And when you're in a web context, Node.js is a common technology choice because it's JavaScript. And yes, you could pick any other language that's out there, but if the UI developers and front-end developers that are building the web app in JavaScript, in HTML, CSS, they're sharing this language with the stuff that they have to do on the backend, and that's just lower cognitive load if they don't have to switch languages there. And when you're dealing with something as common as React, then there's frameworks like Next.js, and that's specifically targeted towards being the backend for the frontend because it supports rendering the React components server-side already. And that's the kind of thing where the React framework itself is going as well with its server-first approach. React, the library, is now cooperating with Next.js, the framework, to figure out this server-side rendering, this server-first approach to building applications, to building React applications, is now the future for React itself as well. It's good to mention here that due to the nature of this code that is server-side, but it is specific to a UI, to a specific user experience, it does cause tight coupling between the backend for the front end and that specific UI experience. It is not ideal to have one backend for frontend and both a native app in iOS or Android or whatever, and a web app calling that one backend for frontend. That's probably not something that is ideal. The idea of the backend for frontend pattern is that there will be 2 backend for frontends in this case, one for each different experience, because the native app will be a different experience than the web app. That is fine. It will also have different needs from the server. And therefore, say you have 2 different teams taking care of these experiences. They could all maintain their own backend for frontend. So the native app team takes care of the native app BFF, and the web app team takes care of the web app BFF, which is a good way to ensure team autonomy. Next, when to use the backend for frontend pattern. There's 4 main reasons you could use this pattern. If one or more of these applies, you could use this pattern, might be a really good idea. If none applies, it's probably not a good idea to use this pattern. Reason number 1 is multiple clients or multiple user experiences. It's like the example I gave before. You have both a web app and a native app. But this situation for some companies is a lot worse. They have not one but multiple native apps, both for iOS and Android. There may even be others. There could be multiple web apps. There could be a specific mobile website and a specific desktop website. Even though I think that's an anti-pattern, there are still some companies out there doing this kind of thing. Serving all these different clients can have very different and conflicting needs from the server. So splitting them up into all separate backend for frontends is probably a good idea. They will all be smaller, they will be less complex, and they may even perform better. The second reason is team autonomy. When you have a backend for frontend, it will cause further decoupling, especially in a situation where the frontend developers are in their own team and the backend developers are in their own team. Causing further decoupling can also be a negative thing, but when it's a positive thing, it's in a situation where you want this domain logic to be pure. You want this backend for frontend, this UI logic, to be contained. That sort of separation of concerns. It's a good idea to have the domain logic separate from the UI logic. This backend for frontend can be purely built, purely catered to the client-side needs. If you don't have a separate backend for frontend, then you will be forced to put this UI logic, these examples I've given them before, like your HTTP redirects, your error page, your 404 page, some headers that you need to have there because you do want the most secure cross-site scripting protection. You need to put them in this generic service. There's things in this may be a Java code base, maybe a different language than what you're used to. So you may need to ask these people in this other team to do this. This will hurt your velocity. They also might not want to because their service is generic and they don't understand this technology. Say you don't have cross-functional teams. You have a team of front-end developers and you have a team of back-end developers. The front-end developers build the client-side application and the back-end developers build either a monolith or lots of microservices, but they build the domain logic. These UI concerns that need to be server-side need to be somewhere. If there's a team boundary, then front-end developers need to either update the code that the backend developers are working on, or they need to ask them to do that. Teams run at different heartbeats, different velocities. This will hurt the velocity of the front-end team because they need to ask and wait, or they need to do and then wait for a code review. Or if they're not doing a code review, then it's also hurting them because they're just updating code that they're not owning themselves fully. There's all kinds of problems that could be caused by not having the UI concerns on the server owned by the people who built the UI. Another example could be if currently the backend uses a REST API, but it sends a lot of data over the network, and the front-end developers want to optimize performance because they notice that the client side is being hurt by sending this megabyte of response when they just simply only want a few fields. The front-end developers want to upgrade to GraphQL as a protocol because it is more efficient for these kind of problems. Now, if they have their own backend for front-end, they can just do that. They don't have to ask, they don't have to wait, they don't have to figure this stuff out together. No, there is a REST API available. They have their backend for front-end service. They can call this REST API, which is closely co-located in the same cluster preferably. So there's a high performance between server to server. And then this GraphQL has the advantage of only sending the right things that the client needs across the network to the browser all the way over the internet. That's the performance optimizations that's being made. And the beauty of the backend for frontend pattern is that the team can own this themselves. The front-end developers can just do this. And the principle here is that if this server-side component, this backend for frontend, isn't owned by the people who built the UI, then it isn't the backend for frontend pattern. And reason number 3 is that the UI is a very separate concern from your domain or your business logic. When your backend services, your business logic are very generic, then you run into a problem. That effectively means, if you want to keep them generic, you don't want to add this UI specific code into this backend repository, into this backend code. Yeah, the front-end developers want a certain redirect. They want a specific header added. Oh, this error page is wrong. Can we style the error page? Can we do something with it? Then again, this backend will not be as generic anymore. It will slowly turn into a web service instead of a specific domain API service. If your domain has a specific feature or capability, you want this to be purely tied around that. If you expose that to the internet, it will get other concerns there as well. It will become a web server. Do you want that? Are you okay with that? Probably not. So let's split these concerns. We need to realize as an industry that there are server-side concerns that are specifically to the UI. The UI is never only client-side. That's not how the technology works. Serving a web app can create very specific requirements of a backend. Just an API is not going to cut it. And the last reason is when you have multiple different services to call. Say you don't have a backend for frontend. You have one client application, could be in Swift if you're building an iOS native app, it could be in JavaScript if you're building a web app, and you have a microservice landscape in the backend where you have, I don't know, maybe 10 or 20 different microservices that are all composed of your backend. Now, calling all these different services is suddenly a burden for the client. You need to have all these protocols implemented, maybe different authentication mechanisms, different ways of calling them. You may need different libraries or whatever to do all that. It may be a performance burden also on the bundle, the JavaScript bundle that you're sending to the client. There could be a lot of reasons not to want this stuff. The backend for frontend can act as an aggregation layer in between. The backend for frontend can model the domain concepts as they're needed by the client, as they're viewed by the client. The domain might be a way bigger domain, but the client-specific needs are just a part of that domain. Then the domain could be modeled as if it is a smaller domain in this backend for the frontend. And using a backend for frontend in this kind of situation causes your client-side code to be smaller, more performant, and less complex, which is a clear advantage. To summarize, the backend for frontend pattern isn't only useful when you have multiple clients like multiple native apps and multiple web apps. There's more reasons to actually use that, even if you're not in that specific context. The fact that UI-specific server-side code is a separate concern is probably a good idea for many different environments. But on the other hand, you also have to realize that the backend for frontend pattern isn't a solution to everything. If you have a cross-functional team, so frontend and backend developers in one team, or maybe even you also have full stack developers in that single team, then it might make sense to get this separation of concerns in another way. You might split up this application in sort of two parts. There's this part of the source code is clearly the domain and the business logic, and this part is clearly serving the web app or the native app that you're doing. Separation of concerns can also be done within a code base. You don't have to extract it as a separate service per se. And that's it. I hope this was helpful. I hope you liked it. If you have any comments, requests, if I've made a mistake, or if you want me to make a specific video in the future, leave a comment and subscribe. Thank you very much for watching.